Universal is known for its disruptive innovations. They were the first to demonstrate reactive control of an industrial robot. First to use the Microsoft Kinect for industrial vision guidance. First to use GPUs for vision processing in robotics. First to couple sensor and motor data to drive cognition. And they have done it again. Introducing the first fully integrated plug-and-play industrial robotic work cell, scaled to human form factor. It combines the ease of use of collaborative robots with the speed and strength of industrial robots. The complete system fits on a 4x4 skid and can be put in place with a forklift. Its compact design allows it to be set into existing manual workstations without modifications. The system is ready to work within hours. What separates this clever work cell from typical integrated solutions is Neocortex, Universal's artificial intelligence software. Neocortex was invented for NASA 12 years ago and developed for industrial applications by Universal. Neocortex provides for human-like flexibility at speeds far faster and more stable than humans. It handles nearly limitless objects. It averages 800 picks per hour, with peaks to 1600. The system is 50% less expensive than labor. It's ideal for random bin picking, order fulfillment, and machine tending, anywhere manual labor is used on the supply chain. Neocortex recognizes a diverse mix of object shapes, from machined parts to consumer products. It can pick in place with 6 degrees of position and pose, while avoiding obstacles in its path. The system can accommodate nearly all containers, including cartons, bags, bins, trays, gaylords, and totes. The human interface is a rugged tablet or panel-mounted touchscreen with simple controls. It easily connects to a warehouse management system. Performance and other data can be distributed through the network as needed. For those occasional times when the robot needs assistance, simple interface tools enable interaction by nearby employees. The cell is designed for maximum configuration flexibility. The robot can be sized for reach and load. The tool can be selected for vacuum, gripping, or both. Single or multiple sensors can be incorporated with a wide range of specifications. Sensors include 2D, 3D, and laser. The system supports most commonly used Ethernet and field bus protocols for reliable communication to PLCs and other devices. Barcode, OCR, and RFID readers are easily added. The collaborative robot ease of use combined with the speed and strength of an industrial robot. Universal. Go for the gold.